Well, welcome back to Chapter 11. We're going to look at our first example. Now, suppose a random sample is obtained from a population that's normally distributed with a mean of 20 and a standard deviation of 12. So we have this random variable x that's normally distributed with a mean of 20 and a standard deviation of 12. Describe the sampling distribution of the sample mean for a sample of size n equal 4. Now, what do we mean by describe a distribution? That means we have to state the mean and standard deviation and the shape of the distribution. So here we're saying we take from the population samples of size 4, and we do this over and over and over and over again. We create a sampling distribution of the sample means. So we need to find the mean and standard deviation, but we've already talked about that the mean would be equal to the mean of the population, and the standard error is just 12 divided by the square root of 4. So our distribution would be normally distributed because it comes from a population that's normally distributed. Remember what we said, whenever the population is normal, no matter what the sample size is, the sampling distribution will be normal. So our x bar is normally distributed with a mean of 20 and a standard deviation of 6. So now if you want to calculate the probability that a random sample of size 4 will have a mean between 16 and 24, we would write that up, the probability that x bar is between 16 and 24. And we'd go on and solve that. So I'd first have to standardize 16 and 24 with the mean and standard deviation of the sampling distribution. So I would say 16 minus 12 divided by 6. Then 24 minus 20 divided by 6. So now I have my z-values. So I'm now looking for the probability that z is between negative 0.67 and positive 0.67. And by using the table A, we get the, remember how we do the in-between, you take the bigger number, the probability that goes with the bigger number, minus the probability that goes with the smaller number. So I'm going to take 0.7486 minus 0.2514, and that equals 0.4972. So the probability that the random sample of size 4 will have a mean between 16 and 24 is 0.4972. Now let's see if we take a sample of size 9 and ask the same question. What's the probability that the mean is between 16 and 24? Now the first question is this the same distribution as what we used in A and B? Well, it's not. It is normally distributed. It does have a mean of 20, but the standard deviation for this sampling distribution, that is the standard error, is 12 divided by the square root of 9, or 12 divided by 3, which is 4. So this is a very different distribution. So now to calculate the probability that x bar is between 16 and 24, to standardize this I have to say 16 minus 20 divided by 4. And then for the right end it would be 24 minus 20 divided by 4. Or the probability that z is between negative 1 and 1. And we know by the empirical rule that should be about 68%, but we can calculate it exactly using table A. So you take the bigger number, probability, so the probability that goes with 1, everything less than 1 is 0.8413, and the probability of less than minus 1, which is 0.1587. So we get the probability that x bar is between 16 and 24 in this sampling distribution, where sample sizes are 9, is 0.6826. So look at that. From part B to part C, as my sample size increased, and I'm looking at the same range between 16 and 24, the probability increased. So what we find out is when we're doing intervals, if we're in a sampling distribution and the sample size increases, the probability of our x bar being in that range will increase. Now let's look at another example. Based on tests of the Chevrolet Cobalt, engineers have found that miles per gallon in highway driving are normally distributed with a mean of 32 miles per gallon and a standard deviation of 3.5 miles per gallon. Now look at these questions. Question A says, what is the probability that a randomly selected cobalt gets more than 34 miles per gallon? Now, how do I know whether this is going to be a sampling distribution of the sample means or just a regular like Chapter 3 problem? Well, first of all, if you don't see a sample size, more than likely you're not in a sampling distribution, or you wouldn't have enough information anyway to answer the question. Also, it's saying what's the probability that a randomly selected cobalt, that some cobalt off the street would get more than 34 miles per gallon. That tells me I'm in a Chapter 3 problem, straight probability from the table, where I'm looking at the population. But look at Part B. It says suppose 10 cobalts are randomly selected and the miles per gallon for each car are recorded. What is the probability that the mean miles per gallon exceed 34 miles per gallon? Well, there it's asking the probability of the mean, and it gives me a sample size. Those two together tell us we're in a sampling distribution, and just like Part C, it gives us a sample size of 20, and it's asking for the probability the mean miles per gallon exceed 34. So let's do these problems. Part A. So this is just the probability that X is greater than 34. Well, I've got the mean and standard deviation of the population, so I'd say the probability that Z is greater than 34 minus 32 over 3.5. In other words, the probability that Z is greater than 0.57. From the chart, we get the answer to be 0.2843. Now in Part B, we need to actually find the description of this distribution. Well, we know that it's normally distributed because it comes from a population that's normally distributed. We know the mean is going to be 32 because the mean of the sampling distribution is just the mean of the population, but the standard deviation is going to be 3.5 divided by the square root of 10. Now you can get the number for that as about 1.11, but when you're using it in calculations, please go on and do everything in your calculator, and I'll show you what I mean. So let's work the problem out. Now that I know what the distribution is, I've described it, I'm now going to solve this problem. So the probability that X bar is greater than 34 is equal to the probability that Z is greater than that X value 34 minus the mean 32 divided by 3.5 divided by the square root of 10. So in your calculator you're going to say 34 minus 32, find out what that equals, put that in parentheses, divided by, and then in parentheses put 3.5 divided by the square root of 10. When you get that, you'll get the probability that Z is greater than 1.81. The reason why I'm telling you to do this is because you want to reduce the rounding error so that you get the same answers that you're going to see, that you're going to match up with, or that you have to fill in. So what's the probability that Z is greater than 1.81? Well, it's 0.0351. Now in Part C, we are in a different distribution. The distribution now is when we're doing samples of size 20. So X bar is normally distributed because, of course, the population is normally distributed, so all the sampling distributions will be normally distributed. It will have a mean of 32 and a standard deviation of 3.5 divided by the square root of 20. That ends up being 0.7826. But again, we want to put that calculation when we're trying to find the Z-score because we want to reduce rounding error. So let's look at the probability that X bar is greater than 34 in this distribution. So that would equal the probability that Z is greater than 34 minus 32 divided by 3.5 divided by the square root of 20. That equals the probability that Z is greater than 2.56, which is equal to 0.0052. So these are the different problems that we see when our distribution, our population is normally distributed. We see the difference between just using the table A straight up, or having to figure out what our distribution is because we're in a sampling distribution. So again, if you see a sample size and they ask for the mean greater than, less than, or in between, then you're in a sampling distribution. So make sure you understand and look at the wording of the problem. So again, Part A is just using Table A. Part B and C are sampling distributions, and you need to define the distribution, and then you can standardize your X bar to a Z.